Okay, so now we're going to look at one special type of reaction called a neutralization reaction. And basically, most neutralization reactions are just simply a double displacement reaction, but your products are very specific. What neutralization is when you take an acid and a base and you react them and they neutralize each other. So in other words, the H's and the OH's cancel each other out, and you end up with a perfectly neutral solution, which is the premise behind the little cartoon strip I have here, because McAllister's aim was true, and he had measured an aliquot, or a sample, of hydrochloric acid, and it found its mark deep in the enemy's reservoir of sodium hydroxide. And he grinned wryly because finally one of the enemy's strongest bases had been neutralized, so he neutralized the base with the acid. Ha ha ha. Okay, so anyways, looking at neutralization reactions, and because the acids and bases are opposites, they will cancel each other out. And that's kind of what we're after here. So we call that process neutralization. And basically, again, it's a double replacement reaction between an acid and base, and it's always going to make some sort of a salt and water. Now you're probably thinking, oh, salt, like table salt, NaCl. Well, that can be one of them. So here is your acid and base making salt and water. But in chemistry, basically any ionic compound can be considered a salt. So in this case, remember, like, we're taking the H's and the OH's. These are your acid ions, and these are your base ions. And if you think about what H and OH makes water, and water is neutral because its pH is 7. So this is why we call it a neutralization reaction. And then basically your NAs and Cl's just end up going together. So here's another example. We could have hydrochloric acid and potassium hydroxide making potassium chloride and water. Still an acid and base making a salt and water. Now again, we use the term salt to represent any ionic compound that's produced in these kinds of reactions. So notice the salt in this example, it's not NaCl, it's not table salt, but a salt in chemistry is basically any ionic compound consisting of positive ions other than hydrogen and a negative ion other than hydroxide. So sodium chloride that we're familiar with, that's just one type of a salt. So back to neutralization. So in this example, the acid provides the nonmetal chloride, and the base provides the metal lithium to make the salt lithium chloride. And then the hydrogen ions and the hydroxide ions get together to form from the acid and base to form water. And neutralization refers to the fact that when the acid and base no longer exist, you get a pH of 7, which is neutral. So here's some examples of acid-base reactions. So let's start off. HCl. So I'm going to write HCl, and we're going to react it with MgOH2. So let's figure out what's going to be made. Well, we know it's going to be a salt. So the salt here will be with magnesium and chlorine. We know magnesium's a 2+ and chlorine's a 1-. So it'll be MgCl2 and then water. So now all we have to do is go back and balance the rest of our reaction. So I need 2 chlorines here. Now that means that I have 2 magnesium, or I have 1 magnesium, 2 chlorines. Now on this side I have hydrogens. I have 4 hydrogens on the reactant side, so I need to put a 2 here to balance my hydrogens, which also balances my oxygens. So we are good. Next one, between HBr and AlOH3. So HBr and AlOH3. Okay, so Al goes with Br, so that'd be AlBr3, because aluminum is a 3+ and Br is a 1-. And then H goes with OH, so it's H2O. Now we just go back and balance the reaction. So I need 3 bromines, so I put a 3 there, which means now I need 3 waters, and that should balance everything. All right, so you guys can try this one, see if you can get the right answer, and then check your answer against mine. HIFeOH2. So Fe was a 2+ on the reactant side because you needed 2 OHs, so I is a 1-. So this is FeI2 and H2O. Going back to balance the remaining reaction. So let's see, we need 2 iodines, so I put a 2 there, which means now I need 4 hydrogens, so I put a 2 in front of water, and we should now be balanced. So that's what a neutralization example or neutralization question looks like.